Not all road barriers protect you the same way. They all look similar, but they behave completely differently in a crash, and that difference can decide whether a driver survives or not. There are four main types of roadside safety barriers: concrete, steel guardrails, cable barriers, and newer systems like roller barriers. Let's break them down. Concrete barriers. Concrete barriers are rigid systems. They do not deform significantly during impact. Instead of absorbing energy, they redirect the vehicle's trajectory. This results in higher deceleration forces transmitted directly to the occupants. However, they provide excellent containment. They prevent vehicle crossovers even at high speeds and sharp impact angles. That's why they are widely used on medians of high-speed highways and in areas with limited space. Steel guardrail. Steel guardrails are semi-flexible systems. They absorb energy through deformation. When impacted, the rail bends, posts yield, and the system dissipates energy over distance. This reduces deceleration and lowers injury severity, but performance depends on installation. Post spacing, embedment depth, and working width are critical parameters. If these are incorrect, the system can fail or become hazardous. Cable barrier. Cable barriers are highly flexible systems. They consist of tensioned steel cables mounted on posts. During impact, the cables stretch significantly. This allows the system to absorb large amounts of energy. Crash severity is often reduced, but deflection is high. Vehicles can penetrate deep into the system before being redirected. This requires sufficient lateral clearance. Cable barriers are highly effective in medians, especially for preventing crossovers. Roller barrier. Roller barriers are energy-absorbing and redirecting systems. They use rotating cylinders mounted along a steel structure. When a vehicle impacts the system, the rollers spin. This reduces friction and converts impact energy into rotational motion. The goal is to guide the vehicle along the barrier, instead of stopping it abruptly. These systems aim to reduce both impact severity and vehicle instability. However, their performance depends on design standards, installation quality, and testing certification.